Hello and welcome to Vodcast 5.2. In our previous podcast, I overviewed evidence for continental drift, and in this podcast, we will talk about plate tectonics. In the previous podcast, I presented a collection of evidence that supports the theory of continental drift. There was one problem with Wegener's theory, namely, he couldn't provide a mechanism that caused the movement of Earth's continents. But lo and behold, we have our mechanism, and I'm going to explain it to you. Plate tectonics is a more powerful scientific theory than continental drift because it provides the mechanism for the motion of Earth's continents. Let's overview some of the key features of this theory. First, it's important to know that Earth's interior has structured layers, and it's the dynamic nature of these layers that causes the plates to move over time. The very top layer of Earth's interior is the crust, and directly underneath the crust is the cool uppermost region of the mantle. When you take those two regions collectively, we call that the lithosphere. The layer directly underneath the lithosphere is the asthenosphere, and this layer is extremely important for the plate tectonics mechanism. The asthenosphere is the hotter, weaker portion of Earth's mantle, and it's in this region that the rocks can flow because they're very near their melting temperature. The key point here is that the asthenosphere is weaker and less rigid than the overlying lithosphere. So what specifically drives the movement of Earth's plates? We're going to return to a concept that we actually talked about when discussing the rock cycle, and that's convection. If you put a pot of water on the stove and get it to a rolling boil, you'll see the concept of convection in action. Put as simply as possible, warmer things expand, and when they expand, they become less dense. By the same token, cooler things contract, and they become more dense. So convection represents this dynamic circular flow of material or energy or what have you. For our purposes, what we need to know is that convection, which is the upward movement of less dense material and the downward movement of more dense material inside of Earth, is the driving force for the movement of Earth's plates. As shown in this image, the warmer plumes will be less dense than the surrounding material and they will rise towards Earth's surface, while the cooling material, which becomes more dense as it cools, will sink back into Earth's interior. I really want to stress the importance of this concept because it'll come up again when we talk about the atmosphere and weather. The last thing we'll look at in this podcast are Earth's plates. You can think of the plates as segments of Earth's lithosphere. And to help you conceptualize how they move, imagine them moving as rigid units relative to the other plates. Now, as mentioned on the previous slide, it's the concept of convection that drives their movement. And in our next podcast, we're going to focus on three different boundaries, namely divergent boundaries, convergent boundaries, and transform boundaries. It's important to note that at these boundaries is where all the action's taking place. Your divergent boundaries are associated with seafloor spreading and continental rifting. The convergent boundaries are associated with mountain building and volcanic activity. And earthquakes are often associated with transform boundaries. But let's go back and focus on the big picture here to conclude this podcast. Alfred Wegener was the champion for the continental drift theory. And although there was good evidence to support his theory, he couldn't provide a mechanism to explain how continents moved. The theory of plate tectonics does just that. On this image, you see all of Earth's plates. And over very long time periods, these plates will move relative to one another. It's hard for us to notice these things in our day-to-day lives, or even our year-to-year lives, because these plates move at about the same speed that your fingernails grow. But when taken over tens of thousands of years, or hundreds of thousands of years, or millions of years, the theory of plate tectonics tells us that Earth's continents can move very great distances, and far into the future, world maps will have to be redrawn yet again. Okay, that concludes this video podcast. In our next video, we will turn our attention to the three specific boundaries shown in this image.